Now that we have learned about the various ways gas cargoes are carried, in this chapter we are going to look at some of the most important safety issues for gas cargoes. After completing this chapter, you will be able to identify the hazardous area zones on gas carriers and outline the precautions required in a dangerous zone. List the types of gas detection which are needed for typical cargoes carried on gas carriers. Describe the purpose and operation of the Emergency Shutdown, ESD. Describe the protective devices fitted to protect cargo tanks. List the basic steps required before loading on a gas carrier. In shore installations where flammable materials are handled, areas are usually classified with regard to the type of electrical equipment that may be used in them. The basic system uses 3 zones, with Zone 0 being the most dangerous and Zone 2 being the least dangerous. On board gas carriers, spaces are usually classified as either gas safe or gas dangerous, depending on the risk of cargo vapor being present. For instance, accommodation and machinery spaces are usually gas safe, but compressor rooms, cargo tank areas and holds are gas dangerous. Because of the risk of explosion, all electrical equipment, whether fixed or portable, used in a hazardous area must be approved for use in a hazardous area. There are many types of approved electrical equipment in use, but here is a description of the 2 most common. Intrinsically safe equipment, EXI, where the energy which can be released from the device would be insufficient to cause ignition of flammable mixtures. Flameproof, EXD, where the enclosure can withstand the pressure developed during an internal ignition of an explosive mixture, and where any hot gases then escaping would be cooled below the ignition temperature before reaching the outside of the device. A Classification Society approved drawing showing where the dangerous gas zone is must be posted in the accommodation. It goes without saying that smoking is banned on deck, but it is also forbidden to carry any equipment that could cause a spark. This includes mobile phones, cameras, cigarette lighters, and any tools which could cause a spark. Any equipment needed for work on deck, like VHF radios and hand lamps, must be EX approved and will be clearly marked as such. Because the cargoes carried can be flammable, toxic, and asphyxiates, the IGC code requires fixed gas detection systems to be fitted. The code says both where the detectors must be fitted and what type of gas detection, flammable gas, toxic gas, or oxygen meter must be fitted. Fixed gas detectors have to be positioned and calibrated for the gas carried. For instance, ammonia is lighter than air, so the sensors are positioned high up, while most hydrocarbons are heavier than air, so the sensors are located at a low position. Typically, gas alarms give an audible and visual warning once a level of 30% of the lower explosive limit, LEL, has been reached. The IGC code specifies where our permanent gas detectors must be fitted, and we have listed the main ones here. Gas detectors must be able to detect hydrocarbon gases, even in an inert atmosphere. In addition to fixed gas detection, the IGC code also requires every gas carrier to carry at least 2 sets of portable gas detection equipment. This equipment must be suitable for the cargoes to be carried and include an instrument capable of measuring oxygen levels in inert atmospheres. The Emergency Shutdown System, ESD, is a requirement of the IGC code, and its purpose is to protect the ship and the terminal. It can be activated manually from several positions on deck, and from ashore when loading. A system which works in parallel with manual-operated push buttons will also be activated automatically in the event of fire. Fusible elements which melt at between 98 degrees Celsius and 104 degrees Celsius are strategically located around the vessel, including places like loading stations and tank domes. These elements melt if near a fire and cause the pressure to be released from a pressurized line. Loss of pressure in the line causes cargo tank valves and loading valves to close. Activation of the system for a fire will also cause the fire alarm to sound and the deck water spray system to activate. The gas code says that emergency shutdown valves in liquid piping should fully close under all service conditions within 30 seconds of actuation. However, it adds that valves should close smoothly and that the closure time should be long enough to avoid surge pressure in pipelines. When alongside, operation of the ESD system will also initiate a dry break of the shore connection to the ship. This can be initiated either manually or automatically from the terminal. It can be arranged to operate automatically if the ship moves excessively at the berth, which might take the cargo connections beyond their operating range. When activated, emergency release couplings part, but leave a closed valve at either end of the break to prevent cargo leakage. Cargo tanks need to be protected from overfilling because this would be very likely to lead to overpressure. They must also be protected from overpressure, which could happen at any tank level due to the cargo warming up. Each tank typically has a high-level warning alarm at 95% full and an independent second high-level alarm at 98% full. If the second high-level alarm is activated, the filling valve will close and any running cargo pumps will stop. The IGC code requires that at least 2 pressure relief valves of equal capacity are fitted to each cargo tank. These are usually operated by a pilot valve to give greater accuracy of the set pressure. The arrangement also helps to ensure that the main valve fully opens and closes quickly. This reduces the risk of the main valve becoming blocked with ice when opened, which would prevent it reseating properly. Many pilot-operated valves have a vacuum lock. This prevents the valve opening in case of underpressure, preventing air from entering the cargo tank and forming a flammable mixture. In accordance with the IGC code, some tanks are built to withstand the maximum pressure differential that could result during cargo discharge and therefore need no vacuum protection. Others can either use vacuum relief valves or have 2 independent pressure switches to give an alarm and stop all suction of cargo liquid or vapor from the tank. Gas carriers are carrying flammable and toxic gases, and the purity of these cargoes is also important. For these reasons, a number of gas exchange processes are carried out. Inerting is the process of replacing the cargo vapor or air with an inert gas which will not support combustion. Inerting can be needed from a number of starting points. Firstly, if the ship has been in dry dock or undergoing maintenance, we will need to lower the oxygen content to a level below that which will support combustion. This requires an oxygen level of less than 5% by volume. Only then will it be safe to introduce cargo into the tank, in the process known as gassing up, without creating a flammable atmosphere. Alternatively, if the tank has been used for carrying cargo, it will still contain cargo vapor. If we wish to enter the tank, then the first stage will be to reduce the vapor content to a level below which a combustible mix can occur, when fresh air is later supplied to the tank. Typically, this requires the hydrocarbon gas content to be lowered to less than 2% before introducing fresh air. Local authorities may have special requirements for the final vapor content if a gas-free certificate is required for hot work. When changing cargoes or grades of cargo, we may need to reduce the vapor content of the existing cargo before we start gassing up, before loading the next cargo. This may also be referred to as purging. So far, we have talked about the different situations when inerting is required. You should be able to see that inerting is often just one part of a gas exchange process, and sometimes we just give the whole process a name. Gas freeing is the removal of toxic or flammable gas from a tank or enclosed space with inert gas, followed by the introduction of fresh air. Gassing up means replacing an inert atmosphere in a tank with the vapor from the next cargo to a suitable level to allow cooling down and loading. For instance, with LPG, gassing up means filling the cargo system with LPG vapor and removing all the inert gas until 100% purity is obtained at the top of the tank. Cooling down and loading can then commence. The gas mixture from the tanks can be ventilated to the shore flare or burned in the ship's gas combustion unit, GCU. For cargoes carried below ambient temperature, cooling down is the procedure carried out before the first cargo is loaded. After gassing up, the cargo tanks are slowly filled with liquid cargo to gradually cool down the tank steel and insulation. The vapor produced by the heat removed from the tank will either need to be handled by the ship's compressor plant or returned to shore. Cooling down avoids excessive boil-off during loading and prevents thermal shock to the cargo tanks, etc. Different cool-down rates are needed for different tank types. For instance, a maximum of 9 degrees Celsius per hour is recommended for a Moss-type system carrying LNG. Since normal air contains 77% nitrogen, and nitrogen is an inert gas which will not support combustion, this is a good starting point for obtaining inert gas. All we have to do is remove the oxygen from normal air and we will be left with nitrogen, an inert gas. Oh, by the way, when we say inert gas here, we mean from the point of view of combustion. Nitrogen will combine with other chemicals. For instance, it combines with hydrogen to form ammonia, and so on. We can either remove the oxygen by using it up in the process of combustion in an inert gas generator, or we can separate the nitrogen from the air using either a membrane-type separator or pressure swing absorption (PSA) type separator. The membrane type uses the principle that different gases permeate through a membrane at different speeds, whilst in the PSA type, the oxygen is removed from the air by being adsorbed onto the surface of a carbon molecule sieve at high pressure. By the way, adsorption means the molecules stick to the surface. It is not the same as absorption, which happens throughout the whole of a material, like in a sponge. In some cases, nitrogen can be supplied from the terminal. Nitrogen generators produce an inert gas with a lower oxygen content and are free of the products of combustion, carbon monoxide, carbon dioxide, nitrogen oxides, and so on. Some cargoes can be put off specification by these products, so generated nitrogen must be used. However, production in a nitrogen generator is generally slower, especially for very pure nitrogen. Here is a recap of the main points from this chapter. On board gas carriers, spaces are usually classified as either gas safe or gas dangerous. Because of the risk of explosion, all equipment used in a hazardous area must be approved for use in a hazardous area. This includes mobile phones and cameras and anything else which could cause a spark. Fixed gas detectors, suitable for the cargoes carried, must be fitted, and there must also be at least 2 sets of portable gas detection equipment and an instrument capable of measuring oxygen levels in inert atmospheres. An emergency shutdown system, ESD, is fitted to stop the flow of cargo in an emergency and can be operated both manually and automatically. Shutdown valves must operate within 30 seconds. But must not close so suddenly that they cause pressure surges. Cargo tanks need to be protected from overfilling and overpressure, and there will be at least 2 independent systems for each of these functions. Inerting is the process of replacing the cargo vapor or air with an inert gas with less than 5% oxygen, which will not support combustion. The IMO says that an inert gas generator must be able to produce inert gas with an oxygen content below 5%, and local regulations may be even tighter than this. For gas carriers, the term purging has two meanings. Firstly, like an oil tanker, it can mean flushing the tank through with inert gas to obtain a hydrocarbon content of approximately 2%, so that it will then be safe to ventilate the tank with fresh air without ever forming a flammable mixture. Secondly, it can mean flushing the tank with inert gas to remove vapors from the previous cargo, prior to gassing up and loading a new cargo. Inert gas can be produced by combustion in an inert gas generator, or by the removal of oxygen from air in a nitrogen generator. Nitrogen generators can produce cleaner, more pure inert gas, but generally produce inert gas at a much slower rate.